Hello students, today we are going to learn Science and Technology Part 1. In Science and Technology Part 1, we'll start with the chapter Laws of Motion. Here in this video, we are going to cover three subtopics of laws of motion, and these three subtopics are motion, distance and displacement, and speed and velocity. Here when we are talking about law of motion, so first we must know about motion. What is motion? So here I'll explain you about motion first. Students, these are the few pictures shown on your slide. First is of the flight of a bird. Second is of a stationary train. Here, in which of the following examples can you sense motion? When you will see the flight of a bird, the flight of a bird, there is change in position. There is change in position. When there is change in position, we can say there is motion. When you will see second picture, stationary train. Stationary means it is not moving. There is no change in place. The train is at one place stationary, and that's why there is no motion. Second one, leaves flying through air. Leaves flying through air. So they are changing place. They are changing place. The leaves are moving from one place to other place. So there is displacement. There is change in place. Whenever there is change in place, it is called motion is there. Fourth picture, a stone lying on a hill. Stone is lying on a hill. It is not changing place. It is not changing place. When there is no change in place, the motion is not there, students. So here there is no motion. So we saw four examples. Our question was, in which of the following examples can you sense motion? So here in first we can sense motion. In second, it is stationary, no motion. Here third one, leaves are flying, there is motion. And stone is lying on a hill, there is no motion. So our answer is, we can sense motion in the examples the flight of a bird and leaves flying through air. Rest other two, when the train is stationary and when the stone is lying on a hill, there is no motion. So we can define motion. Motion of an object. An object is said to be in motion if it changes its position with respect to its surroundings and at rest otherwise. Again I'll repeat, students, motion can be defined as an object is said to be in motion if it changes its position with respect to its surroundings and at rest otherwise. So this is about motion, students. Now let's continue. Distance. Here first I will tell you what is distance is. Distance is the length of the actual path traveled by an object in motion while going from one point to another. And displacement is the minimum distance between the starting and finishing points. Displacement is the minimum distance between the starting and finishing points, students. Let us understand this with the help of picture. When you will see here, students, distance and displacement, here green line represents displacement, whereas the red line represents distance. Students, I have to go to the school, or from school I have to go to the house. What I will do, I will follow the road. Here in this picture you can see, students, from school to road of house, there is a road, so we'll follow the road and we'll go to house. We can't directly go from sky from school to house in a straight line, because in between there will be many obstacles, so we will have to follow the path only. So when we are following the path, this road path, the length of the actual path is called distance. The length of the actual path is called distance. Now displacement, the minimum distance, that means straight line distance, minimum distance between the starting and finishing point is called displacement. So this is about distance and displacement. Students, I'll repeat again. Distance is the length of actual path traveled by an object in motion while going from one point to another. Here, when we are moving from school to house following the road, will say the length of this path is a distance. Length of this path is a distance. But for example, on a Google map, if I have to check the distance between two places, starting point and finishing point, they will not follow. We can draw on map, we can draw a straight line, because on a map we'll just take starting and finishing point and we'll draw a straight line, and this distance of the minimum distance of the starting and finishing point can be said as displacement, students. So it is not an actual path, it is not a length of actual path. Here displacement is the minimum distance between the starting and finishing point, students. Let's move ahead, students. I'll give one example so that you will come to know important point about displacement. Here, Swarali is walking. She walks around a circular field as shown in figure. A is a point, starting point. From A, she starts and she ends to the finishing point. She ends to the finishing point. Here, starting and finishing point is same. Starting and finishing point is same. Swarali walks around of a circular field as shown in figure. As starting and finishing point are same and hence displacement is zero. We are taking, when we are talking about displacement, we are saying that the minimum distance between the starting and finishing point, but here starting and finishing point is same, so displacement will set to be zero. The displacement will be zero. But distance is the total length of the, here this total length of the path will be called as distance. So here, as it is a circular path, the distance will become circumference 2 pi r, or you can say the perimeter of the circle 2 pi r. So here distance is 2 pi r, but displacement will be 0 because the starting and finishing point is same, students. Starting and finishing point is same. Let's move ahead, students. One more example. A car starts from a point P, goes to point Q, and then returns to point P. Now, starting point is also P and finishing point also P. Here, the starting and finishing point are same, students. Here, starting and finishing point same. I'll repeat again, students. A car starts from a point P, moves to Q. From Q, it returns back to the point P, students. It comes back to the point P. Here, starting and finishing, both the points are P only. Starting and finishing, both the points are P only, students. Now, therefore, the total displacement will be 0. Whenever there is starting and finishing points are same, the displacement is 0, and distance will be equal to length of PQ plus length of QP, that is 2PQ. The length 2PQ will be the total distance, student. So let's move ahead. Again, you got the example of displacement, that displacement is 0 when starting and finishing point is same. Now here, whenever we before we'll continue with the next subtopic of this chapter, I'll just explain you a small concept which you have already learned, which you already know. Scalars and vectors. Scalars and vectors. A scalar quantity is a quantity that has only magnitude. That has only magnitude. Whenever we have to represent a quantity and we are using only magnitude, then we'll call it scalar quantity. But whenever there is need of magnitude and direction both to represent a quantity, it is called as vector quantity. A vector quantity is a quantity that has both magnitude and direction. Let's understand this like here. Scalar quantities, length. When we'll talk about length we need only magnitude. It may be 1, 2, 3, 4, 5 centimeter, kilometer, whatever. So here whenever we are talking about scalar quantity, length is a scalar quantity. In the same way, area is also scalar quantity. Volume, speed, mass, density, temperature, pressure, energy, entropy, work, power, this all we don't need direction, students. We don't need direction, and that's why these all are scalar quantities, students. These all are scalar quantities. Now when we'll talk about vector quantities, displacement. See here, students, when we are talking about distance, when we are talking about distance is a scalar quantity, but displacement is a vector quantity. When we are talking here, direction itself need direction, so it is a vector quantity, students. Velocity, whenever we are talking about velocity to represent the velocity we need direction, students. These are the vector quantities. Acceleration is a vector quantity. Momentum, force, electric field, magnetic field, these all are, whenever we are talking about any field we need to uh, show the direction, and whenever we are talking about direction it is called vector quantity. To understand it in more better way, let's continue here. Here, speed is how fast. See, speed is how fast you are traveling. One car is shown. Car moves with the speed of 20 kilometer per hour. Sorry, per second. 20 meter per second. Here, car traveling at a speed of 20 meter per second. So here only speed is given, only speed, how fast the car is traveling is given over here. So we'll say there is no direction is not shown, direction is not given. So we'll say this is a speed, and this is a scalar quantity, students. But when we'll talk about velocity, velocity is a speed in a given direction. Here speed is given plus direction is also given. In east direction is given. So speed with direction called velocity, students. Speed in a particular direction is called velocity, and velocity, as we are using direction, velocity is a vector quantity, students. Velocity is a vector quantity. Let's understand the speed and velocity in more better way. When we are talking about speed, speed is a distance traveled upon time required. Distance traveled upon time required. The distance traveled in a particular direction by an object in a unit time is called its velocity, students. Here unit time can be 1 second, 1 minute, 1 hour, etc. If large units are used, 1 year can also be used as a unit of time, students. But when we are talking about displacement, the displacement that occurs in unit time is called velocity. The displacement, see here, distance traveled in unit time is called speed. When we are talking about distance, it is speed, but when we are talking about displacement, it is velocity, students. I'll repeat again, students. I'll repeat again. Here the speed is nothing but distance per unit time, and velocity is displacement per unit time. We know that Distance is a scalar quantity and displacement is a vector quantity. So speed will become scalar quantity and velocity will become vector quantity, students. So we can define speed is a distance per unit time. Distance per unit time. Unit time may be a 1 second, 1 minute, 1 hour, anything anything. If large unit are used, 1 year can be used, 1 year, 1 light year can also be used, students. So you will take care about unit. So unit means any unit. Now here the displacement, when displacement per unit time is there, we'll call it velocity, students. Always remember, students, always remember the unit of speed and velocity are same. Unit of speed and velocity are same. SI unit is meter per second and CGS unit is centimeter per second. Speed is related to distance. Speed is related to distance, whereas velocity is related to displacement. From formula you can see, students, speed is related to distance, whereas velocity is related to displacement. Velocity is related to displacement. If the motion is along a straight line, the values of speed and velocity are the same, otherwise they can be differ. Velocity is the displacement that occurs in unit time. Velocity is the displacement that occurs in a unit time, students. Speed and velocity. Speed of a body is the distance traveled by it per unit time, whereas velocity of a body is the distance traveled by it per unit time in the given direction. Speed is a scalar quantity, velocity is a vector quantity. Speed cannot be zero. Velocity can be zero, students. Velocity can be zero. Now here uniform and non-uniform linear motion we are going to continue with. So we'll continue this in next lecture. For today's lecture I'll stop here only and I'll say thank you for the day, students. In next lecture we'll learn uniform and non-uniform linear motion. Also we'll talk about speed and velocity related formulas, students, and we'll solve few sums also based on speed and velocity. So for today I'll stop my video here only. Please don't forget to see the next video. It will be uploaded very soon, students. So for today, thank